sine of root x. This x right here is the x from the product rule, right?
When I do the derivative, it needs to be chain rule.
Chain rule. You need to chain rule the sine of root x. Yep. How are you?
I'm on 3 right now.
3? Okay, so y'all are working on the same. Y'all are all working on the same one then.
So then after that, what it's
Now x, yeah, perfect. You got it.
times x?
Yes. That's it. All right, help each other out. Help each other out. What you got? I'm assuming you're good here? Yeah, I'm going to put the answers up. What you got?
So, I guess I had a question. So, I was confused so hard at the beginning of the class because I think I finally put it together now. Like technically, we're doing the chain rule indivisibly right here because you have
Sine of x?
yeah times the derivative of the inside, which
is 1.
So it's that. So I was so confused. I was like, where did we get the?
I understand what you're saying.
The last
Very
one.
very good observation there. Yes.
Yeah.
The derivative of the x is 1 on the inside.
Yeah.
Yep.
So I did this right? So I first do the outside rule,
Yeah.
and then I do the inside.
Yeah. So wait a minute. Hold on.
This is written a little bit differently.
This, I think you did too much at one time there. Yeah, you start with this to the 7th, right? So you bring the 7 out and then you rewrite that to the 6th, just like you did here. And then times next to it, the 2x.
So would this just be 14x? Or are you just telling me to simplify it?
No. Let me write it down. I'm going to put these answers on the board now, and then when you look at it, maybe it'll click. I'm going to put the answers up here. All right, here we go. First answer. Y prime is cosine x cubed plus 1 times 3x squared. Show of hands. First one, yes?
Yes.
Okay. Second one. I tried to trick you here. This should be secant 4x tangent 4x then times 4. You could bring the 4 out to the front. Anyone have questions on that one? Everyone got that 4x in here, right? All right, third one. I know some people are still working on it. Is there a question? No? Okay. Third one was a product rule. Here's your product right there. So you take derivative of the first one, which is 1, times the second one, second function, plus, now you have to take derivative of sine of the square root of x, which is cosine of the square root of x, times the derivative of what's inside, 1 over 2 root x, times, finish the product rule off, x. Yeah? Yeah, that makes sense? No questions?
On to the fourth.
Fourth one. Fourth one is a product rule again, okay? So the derivative will be, okay, I need to take derivative of the first one, right? So I'm just going to ignore that for right now. I need derivative of that. That's chain rule. 7 comes out, x squared plus 1 to the 6th. So that's where I'm like covering this up with my hand. What's derivative of my hand to the 7th? 7 times my hand to the 6th. Times the derivative of what's in here now, 2x. Do you all agree that's the derivative of the first function? Okay, so product rule says derivative of the first function times the second one. So now I'm going to write the second function without taking its derivative. Plus, now I go to take derivative of the second function, which is another chain rule. Right? Chain rule on this. So 10 comes out. I have x to the 4th plus x plus 1. All of that to what power? 9th. Times, keep going, chain rule here.
4x cubed.
Derivative of what's in here, right? 4x cubed plus x, or sorry, 4x cubed plus 1. times, gotta have parentheses here, okay, times
X squared plus 1 is 7.
x squared plus 1 to the 7th. That's your derivative of the fourth one. Questions on that one? See, what I'm doing is I'm doing the product rule here, where I'm treating this whole thing as kind of like my F from last class. This whole thing is like my G. And so everything right here, that's F prime, times this right here is G, plus this whole thing is G prime, and then this right there is F. Right? Do y'all see it? There's no such thing as doing too many chain rule problems. Those words shouldn't exist in the same sentence. I've done enough. That should never be words that come out of your mouth when you're talking about chain rule. I've done enough examples. How about this one? Y is the cube root of x squared plus 1 over x squared minus 4. I'd like for you to think about that for a minute. What do you see? What do you see? See quotient, right? Where's that quotient live, though? Inside of another function, right? The cube root function. So this is a composition and a quotient, but like, what goes first? The composition, right? So I would look at it, if it were me doing the problem, I would look at it this way. X squared plus 1 over x squared minus 4. And I would say that's all raised to the 1/3. That's the way I would look at that. And then I'd bring my textbook in here. And I would say, I have a textbook to the 1/3 power, right? What is the derivative of a textbook to the 1/3 power? 1/3. The textbook to what power? You have to subtract 1 from 1/3. Negative 2/3. And in here goes what? What goes in the parentheses? The textbook. So everything I had in the original. So x squared plus 1 over x squared minus 4. Multiplied by, because this is a chain rule. Now you're free to go inside the parentheses because you've already taken care of the 1/3 power, right? Go inside the parentheses and take the derivative in there. And that's your quotient rule, right? That's your quotient rule. So I'm going to multiply this times, I'm already starting to think about the quotient rule here. Look in here, right? Just focusing all of my attention now on that part right there. I'm going to do quotient rule on that. Quotient rule is derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared, right? So that's why I put this big division bar. I'm going to go ahead and just put the bottom squared here right now. And then I'm going to start filling out the quotient rule on top. What's the top left corner of the quotient rule here? 2x. That's the derivative of the top, right? Next to that, what do I put? The bottom, so x squared minus 4. Now what? Minus, because it's quotient rule. Minus is in the formula. Now, the next piece, 2x as well. That's the derivative of the bottom. And then times the top, x squared plus 1. There we go. We had something to a power, so we brought the power out. It was the something to the negative 2/3. Then we had to go inside and take derivative of what's in there. When we did that, we had to do quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top, all of the bottom squared. Yeah? You could distribute and clean up the top. I'm not going to, but I mean, that would be something that's not too bad. That's your raw derivative. I do not need parentheses like this. I do not need them because I put a dot here. This multiplication in this long division bar implies that you have to figure out what all this is first before you do this multiplication. It would not be wrong, though, to put the parentheses. Questions? Okay, let's talk about the test. A little bit, yeah? Mm-hmm. Let's talk about the test. So the last test we took here, we finished, the last thing we did was finding the derivative. Wow, look how easy that problem would be now for us. If I ask you to find the derivative of that, right? What's the quotient rule, right? What's the derivative of the top? What's the derivative of the top? 1 times the bottom minus derivative of the bottom. 1 times the top all over the bottom squared. And then you could clean this up. This is x plus 3 minus x minus 1 over x plus 3 squared. That's just me distributing ones and negative ones through. You should get 2 over x plus 3 squared. And if you look, the correct answer on the test was 2 over a plus 3 squared. I'm just showing you, like, that was the last problem we did on our last exam, but we had to do it using the definition. Limit, right, all that. Now we have the quotient rule, we can do it without the limit. All right, so that means that on our next test, where are we going to start? Well, what did we do after this? Let's look at our schedule. Let me bring up an old exam. I think that might be the best way to do this. Let's look at a spring exam 2. So I'm going to send you all something, okay? It might even be this. I don't know. I need to take a look, but find the equation of the tangent line to that curve at that point. Now, on this test, do you see I told them they had to use the limit definition to find the derivative? Okay, so I don't think I'm going to ask you all to use the limit definition for anything on this test, so that really wouldn't apply. Although I could ask you to do that question, right? But I allow you to take the derivative any way you want. And I think you would be okay with that derivative, yes? But do you know what you would need to do to find the equation of the tangent line at a point? Well, that's why you got to review for this test, right? Yeah, to take the derivative, that's just what, 6x minus 1? But the thing is, what do you do with that? That's the slope. You plug in the x is -1 into that. You find the slope. Then you use y minus y1 equals m times x minus x1, all that game. All right, here, this is really where we start getting in. I gave you all a quiz over that problem, didn't I? I gave you that problem as a quiz. Yep. So that was a problem on a test, right? I said, hey, here's a graph of f. Graph me the derivative. I would be comfortable with that. All right, then here's a function. Find the second derivative. Find f double prime of 1. You think you could find the derivative of that? Yep. You would just use power rule, right? Term by term, because there's pluses and minuses between those. You'd find the derivative twice, and then you plug 1 into that answer for x. That seem fair? Yep. Number 4? How do you do number 4? Ask for the derivative here. Please don't do quotient rule on that problem. You can, but I'll just be like, whoa, you're making this way harder than it has to be. What could you do instead? Break it into 3 different fractions, right? Do y'all remember me doing that? And then once you break it into 3 fractions, you rewrite it as x to a power. Look, somebody on the test is going to do quotient rule on that, and it's going to be really a pain in the ass for you. Please don't do that. Okay, what about this one? If f of x is 3x squared minus 7x plus 1, find all values of x where the f has a tangent line parallel to another line. Can somebody tell me, like, generally what you have to do there? Set what equal to the slope? Well, not the original function. The derivative of the original. So you take the derivative of that function, and you set that equal to the slope of that line, which is, what's the slope of that line? 8. The slope is 8, right? So you're basically setting the derivative equal to 8. That was like a homework problem, right? Number 6, if f of x equals sine of x plus x, where does f have horizontal tangent lines? Let's do that problem. If I give you a function f of x equals sine x plus x, and I ask you, where does this function have horizontal tangent lines? What am I really asking you for? Set what equal to 0? The derivative. I want to know where the derivative is 0. That's what this is asking. So you have to understand that from the question, that this is really saying, where's the derivative of this function 0, right? That's what we're asking. So you have to take derivative of that function. What's the derivative of that function? You can do them piece by piece, right? Because there's addition. Cosine x plus 1. Set that equal to 0. Solve for cosine x. You get cosine x is negative 1. Right? That's what we're trying. That's what we need. We need cosine of x to be negative 1. So what this is really asking you is, where is the cosine function equal negative 1? And this is where everyone's going to have different backgrounds on this. The way that I do this is I use a unit circle. And I'm asking myself, at what angle do I have a cosine have a value of negative 1? And cosine is always the x-coordinate on the unit circle. So at what angle is my x-coordinate negative 1? At pi, right? Right here? Because that's the point negative 1, 0. So that's at pi, right? However, we could have an infinite number of answers, right? Because we could come back around and be at pi again as well. So the solutions to this are x has to be pi plus any number of full revolutions to get back to that point. So 2 pi is a full revolution, and then we usually use k or n to represent an integer. That look familiar at all? Yeah?
You want plus or minus or just plus?
Well, it's implied k is an integer. It can take on negative values, so you don't need to put a plus or minus. Yes?
Could you elaborate what you meant on number 4?
Say again?
Could you go over number 4?
Oh, elaborate on 4?
Yeah.
Yeah, let me bring this projector down. So, any questions here?
Yeah.
Yes?
So you don't have to put plus or minus pi?
No, because k here, k, see, and I should actually state this. I'm not stating it because it's kind of understood, but I will, if this were a real, math paper or something, right, that we were submitting, we would have to be clear on what k is. K is an element of the integers. Now, have y'all seen this before, right? That's all the real numbers? That's all real numbers. Fractions, decimals, everything. Everything. This is what we call the integers. And the integers are not all the numbers. It's only the numbers 0, 1, -1, 2, -2, 3, -3, forever, forever, both directions forever. So it's all of your like whole numbers, counting numbers, positive and negative. And so if I tell you that k has to come from this set, then it includes both positives and negatives. Who asked that question? Okay, yeah. So do you see I could let k be -2 and then it's going to go backwards and give me negative rotations. Good? So you don't need a plus or minus. Okay, any other questions here? All right, so for that one, x squared minus 4 root x plus cube root x all over square root of x. I want you to find the derivative of this, right? So my recommendation is to first break it up into 3 fractions. You're allowed to do this only because you have a single term in the denominator, right? You have a single term denominator, multiple terms in the numerator, so you can split this up. Then I would rewrite these as x to powers, so x squared over x to the half minus, these just cancel, don't they? That's just -4, okay. And then plus, this is x to the 1/3 over x to the half. This is starting to make sense what I mean here, like where I'm going with this? Yeah. I'm going to take this. I haven't taken any derivative yet. There's no derivatives. I'm just using properties of exponents. That will become, what is that? What's x to the second over x to the half? X to the 3 halves. So you're taking 2 and subtracting a half. That gives you 3 halves minus 4. And then plus x. And now I take 1/3 and I subtract a half. Minus 1/6. That's the original function, right? Just rewritten in a different way. Take the derivative of that now. Taking derivative of that's, I think, a lot cleaner than quotient rule. It's 3 halves x to the half minus derivative of 4 is 0, so it's not there, plus, actually it'll be minus because this -1/6 comes out. X to the, I subtract 1 from -1/6, I get -7/6. That's your derivative. That's what I mean by split it up. If you do quotient rule, it's just going to be nasty. It's going to be ugly. If you, on the test, if you have a problem like that and you decide to use quotient rule and you do it all correctly, I'm not going to take points off if you do it right. I'll just kind of sigh a little bit and shrug my shoulders and be like, I guess they just don't want to listen. It's okay. All right? All right, so we got that. We got 5. All right, now look at the rest of these. Oh, wow. So I guess in this class I got a little further. But so the number 7. So I'll probably have some problems that are intermediate to these. I think number 8's fair. That's a quotient rule, right? No chain rule at all, just quotient rule. Number 7 and number 8, 7 and 9 are both a little involved. I mean, not terrible, but this one is product rule, right? Product rule, but that's got some chain on it. And down here you've got chain, right? All like three functions composed. Square root of, sine of, x squared. I don't really see myself doing this as much. Now look, I mean, that just means it's on the next test, but I would be focused more on like the power rule, product rule, quotient rule, and then some simple chain rule stuff. 2 functions together, right? Stuff we did today. on the lighter side. I'm not going to go and be too crazy with the, not that I think this is too crazy, but I'll just save it for the next test. That's a pretty straightforward test, if you ask me. There's not a whole lot in here, right? You've got to know graphs. What the graph, if I give you a function, right, can you show me what the derivative is? You've got to know your power rule, quotient rule. And then the underlying theme of all of this is you should always be able to find me the equation of a line, right, that's tangent to a curve or parallel to something. Seems like a short test, if you ask me. Yeah. Questions?
Something like 10 would be on there?
What?
Something like 10?
No, 10 is not, we haven't covered 10. Yeah, so, I mean, this test was only 10 questions, pretty short. I don't know how long yours will be. I'll make it where I think it'll take you the whole class, or, you know, that most students will finish it within the class time. Yeah. So we come in here on Tuesday and just come take test and you leave, right? That's all we're doing. Anything else? Yes. Uh-huh.
It was on one of the problems we did earlier. It was finding the derivative of y equals secant 4x.
Mm-hmm.
Can I see the steps of how you would approach that problem?
Secant of 4x, yeah. If you're good, you're free to go. If not, I'll hang out and answer questions. Study. Yes.
Well, the homework, is it okay if I turn it in tonight? Like before?
Yeah, absolutely. So if the way I'm doing this is I see composition. I see 4x inside of secant. Okay? So I'm just asking myself what secant of this is. So let's just, instead of using that rag, let's just make this a box. Okay? So if I'm asking you to take the derivative, right? The derivative of secant of a box. I look at my formula sheet and it says that the derivative of secant x is secant x tangent x, right? So I'm going to write secant of the box tangent of the box, right? Understand? So I'm going to write that down. I'm going to say, okay, I'm taking derivative secant of something. It's going to be secant of that 4x, tangent of that 4x. But then I have to remember to take the derivative of what's in here, which is just 4.
That's it?
That's it.
Okay.
And you can put the 4 out front if you want. Just this 4. This 4 can go out front. These 4s are trapped with the x's.
Gotcha.
Do you want us to just do 2.5 for Tuesday? Because 2.5 and 2.6 are due on Tuesday.
Yeah, no, we're not. I would say, I'll send an email out. When I send the review, I'll send something out to clarify, like, look, don't worry about the chain rule stuff to turn in. I mean, I would look at the problems for chain rule, practice them, because we will have some chain rule on the test.
It's a simple chain
Yeah.
stuff. Okay,
Yeah,
I just
but-
want to make sure I don't go too over the hummer.
Yeah, don't go trying to do implicit
exactly.
differentiation and stuff. Yeah. All right. Yep. Any other? Yes.
So go next week for our AirPods.
Ooh, I can probably sell those, right? Do you know her name? Do you know her name?
Is she that
She's the
little one?
third. She's the third seat.
She has, yeah, she has like a hat on all the
Yeah,
time.
I know her.
You know her?
I really do know her. Yeah.
You do?
I went to high school with her. Yes,
Okay. So you gonna see her today? Or
Yeah.
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 All right, it's on you now. All right.
She comes back next week.
Yeah, we're all gonna come looking for the AirPods. Let me turn off my thing here.